Okay, hello everyone. So today will be the last lecture, okay, for the calculus, and uh, reminder for your final exam next Friday, 3:20. Okay, the classroom is the 406 beside this room. Okay, and there will be no class next week. So today will be the last lecture. Okay, so there will be no class on Monday, and also the Friday no class. Okay. So today I'll just set up some exercise for you, and maybe if you have any questions, you can ask. And around 11, maybe 11:20 or 11:30, I will give the last quiz results to you. Okay. And your chemistry is Wednesday, right? Not Thursday, right? Wednesday, right? Chemistry, right? Right. Okay. Okay, let's start the exercise. Maybe I will start from the chapter 6, okay, chapter 6, and then maybe chapter 5 or 7. Um, so let me set the region. Oh, wait. Is rotated about x-axis. Find volume of resulting uh, solid of revolution. So this is the first one, and maybe the second one is rotated about the y-axis. Okay, let's start from uh, the volume. Okay, so it's chapter 6. Similar with the one with your quizzes. You just want to check whether you understand the volume or not, okay, and how to set up the integration. So the curve is y equal cosine squared, and then the interval is from 0 to pi over 2. The first question is the region rotated about the x-axis, and the second question is rotated about y-axis. And see the the volume. Okay? See the volume. So basically, if you have the problems for finding the volume for integrations, meaning you need to choose between two methods, okay? The this method and the shell method. Okay? And how you choose is depends on what the curves looks like. Okay? So if you have the curve, maybe like that. Of course, if you rotate here and rotate here, the x and y, you'll see the differences, right? If you rotate to x, we can imagine the area rotated like this one. Okay? So it's making a solid structure. You can imagine it's like how to say that, like this structure, right? And when you rotate to y-axis, it will be like a toilet, maybe like a toilet. Yeah. So you need to imagine these two image, okay? These two image. One is really solid image. One is having a cavity or having like a notch or like a like a toilet. So choosing the methods is, I think, essential. Okay, because some curves can be solved only by the shell method. Okay, but the other case you can solve by both. Okay, so I think I have checked some of your quizzes. Some numbers, I think I forgot one or I think only one. Yeah, I think one problem you can solve by both methods, and you need to check later if I make mistake. Okay. Uh, I give both full points. Okay. Okay. So let's get some picture of the cosine squared. So cosine squared. Let me just draw. Maybe I just draw like that. Okay, for the cosine squared, and make it 1 and pi over 2. The first one is just rotate the x-axis, right? So we can set up the idea for integrations, okay, to make your solving problem easier. Draw the rectangle. Okay? Draw your rectangle like this. For example, this is the x. Okay? Actually, you can also try to imagine if you put the dy if you want. Okay? But because I think there's nothing wrong with the image, I can just set up the dx and just solving the dx. Okay? So then this method, if you don't really remember what the volume is, okay, and I don't suggest to remember the formula, remember this cylindrical or the disc. Okay? You have the area and you have the height, right? It's basically area times height, right? Or pi r squared, and then the height is just the thickness. The thickness, you can say it's dx or dy, depends on your functions. Okay. Now the integration is from 0 to pi over 2, and then it's only cos squared x and then squared. Okay. Now, how to solve the cosine squared? Okay, how to solve cosine squared? And can you try to solve this first? Okay. Okay, if you have cosine and then squared, what's your best approach to solve? What do you think? Yeah, what do you think? Yeah, but I think it's wrong. Yeah, the double angle. Yeah. Yeah, this one. You need to like square the cosine. So every time you have uh, maybe sine squared or cosine squared, both of the basic trigonometric, uh, my suggestion is remembering the double angle for cosine. So cos 2x is, let me write the all possible, and then you can derive, it's becoming this or this, okay? So if you have cosine squared or sine squared, you can exchange the cosine squared or sine squared into the cos 2x, okay? And that is our cases now. Now we can simply, oh wait, I need to chart this first. Okay, try by yourself first. So you can exchange the cos squared, our questions, with the cos 2x, okay? And by doing that, we can simplify the solution. Because if you have cos 2x, you can immediately integrate, right? Okay, and it become the sine 2x and then over 2. Okay. In case, oh, let's see. In case you are uh, maybe forgetting this too, okay? Maybe you forgot this too. Always make a reverse and take derivative to make sure that your answer is correct and your logic is correct. Okay? So take the derivative of sine. Maybe you forget this over 2. Okay? Take derivative and it will be cos 2x, but you need to multiply with the chain rule, right? 2. Oh, you have 2. It's different, right? So that's why you need to divide by 2 to make it to make the correction. You get the logic? Okay. So every time you're doing the integrations, and if you think you can reverse it very quickly, try to make sure that, okay, the integration is correct because, okay, if I derive, I will get back the original equations. Okay, that's uh, one strategy to check whether your answer is correct or no. Okay. Unless maybe the process is too complicated and you don't have time to check. But if it is still like in simple and not really that complicated, you can check the reverse of your process. Okay, you can check that. So I will plug in the. So I will change the cos squared x with um, 1 plus cos 2x, and then it's squared. It should be half, but I will put half outside and then squared and become over 4. Okay, like that. Now we need to solve this first and try to see the expansion, what the equations looks like. now you're getting the other squared, right? Other squared, cos squared 2x. Now you have this. Okay. Now you have cos squared 2x. And by doing the same thing like we did, we can make it the double angle and make it 4x. And then I think it will be solvable and make it easier to integrate. Okay. And let me make the bracket and 1 plus cos 4x and then over 2. Now it's dx. Now we can integrate all separately. So 1 becomes x, and then this becomes sine 2x over 2, and then multiply by 2, and it will canceling. And plus half x plus sine 4x, 4, 2 becomes 8. Okay, and then it starts from 0 to 5 over 2. I think you can solve this, and my calculation is 3 over 16 pi squared. Is it correct? Have you tried this, right? Okay. Okay. So I hope the sine square or cos squared or the trigonometric integral, I hope you can solve this if you see in the exam. Okay. Now moving on to uh, the second question, rotated about y-axis. Okay. So the first is the x-axis. Now the y-axis. So let me draw one more curve. Let's say this is the curve. This is our curve. And then my rotation is here. So you can have this, the same disk if you want, and it will be dy. But if you are doing this, then you need to make the solution for the curve in x. And then maybe it will be having an inverse, right? And I think that will make your life difficult, right? So I think you can just make it the dx, and then you can do the shell method. Okay. If you want to avoid finding the inverse for this cos squared x, okay, I think that is difficult. Not difficult, but maybe you need to solve for x first, and that takes time, right? So you can just instead solving by the dx. Okay, and then it will be having this shell method. And shell method is basically if you have this, okay, with the certain thickness, it will be 2 pi r and then h, right? So it's h, and then this is r, and then the thickness is dr, right? So we can set up the formula. So volume is 2 pi, and the same interval in x, 0 to pi over 2. And what is our r? So maybe here is r, right? Our r is just x, right? In x-axis. So we can just set up x, and then the curve is cos squared x, the height, and then the x, the dr. Okay. So we can set up the double angle for the cos squared. So I will write this as 1 plus cos 2x over 2 and then dx. Oh, I will cancel the 2 directly, right? And then I will have x plus x cos 2x. Okay, x is easy to integrate, and x cos 2x is a typical problem for integration by parts, okay? Integration by parts. So you have x and cos 2x as two elements. The first one is easy to differentiate, become 0, and then cos 2x, you can integrate sine 2x over 2, and then it will be negative cos 2x over 2 to 4. And then you can set up volume plus minus plus x cos sine 2x over 2 plus cos 2x over 4. And then plug in 0 to pi over 2. Yeah, I think you can finish this by yourself and calculate the number. Okay. Let me check the other problem that we can take on today. So in the final exam, it will be similar structure with the midterm. So you will have the direct questions and also the analytical problem, okay? In which the process itself, how you write, it should be not very long, but you need to analyze the questions or the graphs. Okay? So let me give you some examples. Okay? Some examples. So if f is continuous and okay, so if f is continuous and you have that integration equal 4, then this is the question. Okay, this is the question is equals. So first you need to understand the questions and analyze from the integrations first. Okay, let it try and see your results first. Oh, you have any idea? 2 pi r l, 2 pi r h. R is the radius, h is the height, and then dr, the thickness, the last one, 2 pi r h dr. Just that. How about your other course? Is this okay? Is this fine? Okay. Chemistry is fine. Physics? So, or still not sure. No quizzes. How was your midterm? Okay, around 20, 30. Okay. Okay, how about your other courses? Chemistry, how about chemistry? Like in the middle. And how about physics? What? Physics unpredictable. Okay. How about you? You do chemistry and physics. Okay. Or no? And it's how much? The midterm, your midterm. Oh, okay. Okay. Then your your physics score. Yeah. Good. Uh, low. Okay. But how about chemistry? Chemistry. Is it good or low? High. Okay. 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 Anyone fine? You solve it? No? Yeah. But try and error. Try and error this method. Good. You solve it? And then yeah. Mm-hmm. Mm-hmm. And then can you solve it? No. So the key is to make the u squared is like this one. So yeah. Okay. So you need to say maybe try another u. To make the u squared is u. Okay. Or maybe you can substitute u squared with another maybe v to remove the square, and then it will be similar to this. So v is u squared, you derive become 2 2v. Yeah, twice. You can substitute twice. Mhm. Yeah. Because it's the definitions, right? Yeah. Yeah, you can substitute one more time. Yeah, you can substitute to make it like this. No. I mean, statistically useful. Mm. Yeah. Yeah. I would half, right? Okay. Yeah. Sure. Okay. Okay. I think it's actually a little bit tricky. Okay. So the idea for the question is, you see the information this question gave, the f x dx equal 4. Okay. Uh, so the idea is to make this f is having the fx, okay? Or maybe I will try to write another variable, maybe u. Okay? So you can check the this x squared minus 2x plus 1, you can factorize, become x minus 1 squared, right? Maybe the first time you try, maybe you try the u is x minus 1, and then the u is dx. But you have the minus u, and then this is f, and then u squared, right? And then, oh, you stuck here. But actually, you can substitute many times. You can substitute one more, and it will be maybe v. So you have dv, and then 2u du. And anyway, you will realize that actually it's half of our integration, and the answer is 2. Or at the beginning, you can actually substitute directly x minus 1 squared. Okay. And then you get the deu is 2x dx. And by doing so, you can have the half and then 0, 1, 0. And then this will be 1, and then this, right? And then this will be du, and you will have, in which this is the 4, and you switch the 0 and 1, and it's become positive. So this is 4, so it's 2. Okay. So you can directly substitute with the x minus 1 squared, or you can substitute twice. Okay. It will be the same results. Okay, the same results. Okay. Um, okay, let me give you another question. Oh, any questions about this? What do you mean? Oh, this one? Oh, this I make mistake here. Sorry. This should be okay. So this is the substitution. So the x is okay. Okay. Yeah, I mixed the problem. Sorry. Okay. Another questions. Okay, evaluate. Okay, that's a good question. Just that. By the way, because we only have time until maybe 11:30, and then I will deliver the quiz. Uh, because I also did this exercise with the other class. So I will attach some notes later in the Moodle, so you can have both notes, and I'll also send the other class your notes today. Okay. Because yesterday we did very interesting integral. Okay, but maybe I will write just for your information, and maybe if you have time, you can try it at your home. If you want, you can try this integral, but maybe later. But we don't have time today. At least I need uh, around 1 hour. And maybe later in the Moodle, I'll also attach the notes for this integral. Maybe if you curious. Yeah. But now focus on the questions. Integration from 0 to 1 of this rational functions, x squared plus x plus 2 over x squared plus 1. Hmm. Okay. Very interesting problem. If you see the pattern, you can solve it under 5 minutes or maybe 2 minutes. Mm-hmm. Mm-hmm. Yeah, yeah. Yeah. This is the question. The question is having this, right? Yeah, this is uh, it's the definitions. Okay, any variables defined inside this function will be formed, right? Right. So you can have the set is based on the definitions. Yeah. Can you catch up? Okay. 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 Mm-hmm. No. That's different problem. Okay. Huh? Okay. The bottom one, the square tangent x, is different problem. Okay, different problem. Okay, not connecting to the first one. Okay. No idea. What you do? Yeah. The tangent is maybe later at your home. That's very. I can solve it around almost 2 hours. So that's very difficult. I will not uh, write this in the exam. Oh, good. Yeah, you will definitely get the result. Any idea? Can you separate into design? Hah? Iya, bisa pecah. Pecah biasa aja, nggak usah pakai yang pakai ABC itu nggak usah. Pecah biasa aja. Get the result? Mm-hmm. Yeah. But you can separate in different forms. This way it's difficult, but you can separate in different form and it will be much easier. But the idea is separate the fraction. That's the idea. Okay. Can you separate this into two fractions? I think it's a good idea. Can you separate become two? So x over this and 1 over this. Integrate each one, right? I think that is, yeah, that you will get the result. Yeah, good, good. You have fractions, right? Yeah. Any idea to solve? Yeah, correct. And this, see, you can separate become two, right? X over this and 1 over this, right? You can separate, right? And then easy to calculate. How about you? Yeah, the idea is to separate the fraction, but I think this will be difficult. And this will be difficult, right? Maybe you need to think another separation. Yeah, yeah. Correct. Okay. Separate. Become two. This one. Separate become two. Two fractions. Yeah. Correct. Okay. Okay, I think you can. Uh, I saw some of your works, and it's quite a tricky problem, but it's quite easy. It's quite easy if you see the patterns. Okay. First, maybe you think that you can separate become this, but it is resulting the difficult problem here, right? Okay. So how about I writing the x squared plus x? Okay. Instead of two, I will separate one and one. Okay. So I will get the first one. I will combine this. So x squared plus one, x squared plus one plus x, right? Plus this. And then I will integrate all nicely, right? right? Yeah, it's just playing the number and then you can separate, right? And this will be 1, right? This is the x and then plus. The second one you can solve by substitutions, right? You can substitute, let's just substitute u is x squared plus 1 and then du is 2x dx. So you will have half. So let me just write the answer directly. So x plus half ln x squared plus 1. And then this part is tangent inverse, right? So tangent inverse x. And then it's from 0 to 1. So I can put in all the constant. This is pi over 4, right? So this is the answer. Okay. So sometimes by playing the numbers, and I know that because uh, it seems that the question is forcing you to separate and maybe using partial fraction, and you are thinking to make the a, b, c constants, right? But actually, it's the you can see that it's plus plus plus, so you can see that it can be each one of the fractions, and um, because before it's 2, right? Here is 2. If you are just taking 2 and then x squared in each separate integrations, maybe it will be difficult to solve. But if you using and make 2 as 1, 1, you can play nicely here, right? And this become x squared plus 1 over x squared plus 1. It's become 1. And the other one you can solve by each one its substitutions and this tangent inverse. And like I said before, you can solve it like under 2 minutes or under 3 minutes if you see the patterns. Okay. Or actually, I think so. I saw that some of the students you try to just divide, right? X squared plus x plus 2, and then just divide by the x squared plus 1. This is also correct. And you just getting the x squared plus 1, and then you get the x1 plus 1, right? And you get the 1 plus x plus 1 over x squared plus 1. And this also, you can separate, right? And still the same result. And it's also because because the functions, the number is just not too complicated. You can calculate faster, right? And this will be resulting the same result. Okay, let me give you maybe a little bit. Which one? Okay, let me make another page. Uh, Maybe evaluate. Now this is maybe to take around. So it's combinations of the improper integrals with some techniques of integrations. Okay. So you have to two problems. Okay, solving the integrations using the limit, right, with the improper integral, and solving the inside integrals, the using some techniques. Let me give you some minutes, maybe 5 to 10 minutes to solve. Can you catch up? Yeah. Do you understand this problem? Yes. Mm-hmm. Okay, okay. How about your other courses? Chemistry and physics. Uh-huh. How about your score? Chemistry? How about chemistry? Average? Physics? Okay. How about you? Very good. Okay. How about physics? Quite low or quite low? Nah, bisa ngikutin nggak? Sejauh ini bisa ngikutin semua mata kuliah bisa ngikutin. Kimia bisa. Oke, oke, oke. Ivan? Yeah, it is crazy. Really long. Really long. I solved maybe around two hour. Okay. Uh, let's observe the form. Okay. You have x with 4 and then over 1 plus x to the 6. And it's a squared. Okay. So maybe to make it simple, maybe we can square it and then make it x to the 8 and let it be the 1 plus x 6 and then square. Okay. And you see the x with power of 8 and you have this 1 plus x to the 6 and then squared, right? If you see this problem, the first thing that instinctively usually comes to your mind is, can I substitute 1 plus x6 and x8? I think if you directly approach that method, you will not get any results, right? Because you need to think what is your substitution, right? If you substitute the 1 plus x, because it has 1 plus that you want to cancel, maybe you want to substitute this. But if you derive, it will have, right? And then the x. This is 5, this is 8. But what if, what if this is 5? It's possible, right? And then maybe it's 3 here, right? That's the idea, okay? So, so this part you can substitute, you can integrate, okay? So this part can be integrations, and the other part can be derived, right? And you can use integration by parts. Make sense? Make sense? Okay. That's the first step. The first step. So let me help you to write over here to see clearly. So I can write this. Let me just write the indefinite integral first, and later we go back to the improper one. and then you can solve by the substitutions. So you'll get the dx is du. And you will get the result is, this is 1 over u squared du, and this will be resulting negative 6, this right. So I can write back to, maybe go to, so negative 1 over 6, oh maybe 1, 6, okay. So now I get this positive, negative. So I can write the solution is negative x cubed, and then 1 plus x to the 6 plus the integrations of, it's half of, let me write half outside here, and then x squared over the 1 plus x dx. Okay, now we still have the integration. We are not done yet. We still have this. Okay, what's next now? How to solve this? Okay. So any idea to solve the x squared and then over 1 plus x with the power of 6? So first step is you can set up the integration by parts. Okay? Okay. The idea is come from, if you substitute 1 plus x with the power of 6, what function or what equation need to be here. Okay? And you can separate 5 and 3. You can solve by parts, but we still now have the integration of x squared over 1 plus x to the 6. Any idea to solve? Okay, you have x squared and then you have 1 plus x with the power of 6. Ah, okay, correct, correct. Okay, anyone solve? Okay, see, the form is x squared and then 1 plus x 6. Okay, the trick is, okay, if you see any kind of this thing, let me give you another idea. If you see any integration that comes to mind, okay. Whenever you see any maybe x squared or maybe some power here over maybe square root and then maybe a constant plus x squared or maybe a constant minus or maybe x squared minus this square root, okay, over here, it will give off the idea to solve with the trigonometric, right, substitution, and you can solve it by, but if you have uh, maybe x with power 2, like that one. And then you have the 1 plus x6. You see the 6 power here, okay? And remember also the, so if I can remove the x squared, okay, and I can make this, because it's constant, like for example, if you have a plus x squared, you have integrations, you can have this tangent inverse, right? And it's 1 over a, right? You can have tangent inverse. Can you manipulate this x6 becoming this squared? So you need to use another substitution to, to rewrite this form, remove this, and make it this as squared. Okay. So the idea, what I mean is, if you make another substitutions, okay, um, maybe t. If I derive this, it becomes 3x squared, okay, in which we can cancel the x squared, right? And become 1 over 3, right? And then I can write this integrations become 1 over 1 plus, let's say, t, and then squared. Okay? So t squared is x with 6, right? And then it's dt, and 1 over 3, and it's become 1 over 6. And this is precisely become our tangent inverse of t, right? And t is x cubed, so I can maybe directly just give the x cubed here. So 1 over 6 tangent inverse x cubed. So the formula will be negative x cubed over 6, 1 plus x6 plus, okay, and plus c. Okay, okay, at least we finished the integral, the integrations. Okay? But we are not done yet. The question is improper integral, so we need to put back to the original questions. Okay? So uh, let me write limit as maybe t approaching infinity. What is the questions? Negative 1 until t. Let me put back the original questions first. 1 plus x6. And then let me just write the directly the results. So negative x cubed 1 plus 1 plus x plus 1 over 6, and then tangent inverse x cubed from negative 1 until t. Now you need to solve this first. Plug in the t. It will be negative t cubed, and then 6 plus, or let me just write just 6, and then 1 plus t6, and then plus 1 over 6 tangent inverse t, and then minus, so negative 1, it's still negative 1, multiplied by negative will be positive, just 1 over 12. And then plus 1 over 6 tangent inverse or I will just write tangent inverse -1 first. So we can conclude this is 0, okay, based on all the limit, okay, divide by the highest degree, divide by t cubed, p cubed, t cubed, and it will result 0, 1 over infinity, right? And this part is tangent inverse infinity is pi over 2, okay? Pi over 2, and then minus the 1 over 12. So this is 0 plus. So this will be minus, uh, it's negative pi over 4. It's -1, right? So it's resulting the results. Let me check my results. It's pi over 8 minus pi over 1 over 12. Okay. Wait a minute. Okay. Um, Let me disconnect first from the, and then, okay. So this is the result, and uh, always remember, okay? Always remember, every improper integral, you need to you need to solve it by limit, and you need to remember all the property of limits. Okay. So if you have limit as some t approaching infinity, when you plug in t and you solve the t, if you can manipulate the equations become 1 over t, then it will be a 0 in limit, right? And you can do that this part. Okay. I think the other part you can solve it. And remember, the tangent have infinite value in certain area, right? So you can, and you, at least the sine, cosine, and tangent. I hope you are familiar with 3 of them because uh, in the quiz, I think a few of you, some of you, you didn't remember how the tangent or the sine looks like. So please remember the graph. That's the really fundamental graphs for all math. Okay. Okay. And because now it's already 11, 11:57, I need to deliver the quiz to you so you can check your score. Okay. But before I give you the quizzes, uh, can I have a photo session with you? Because today's the last lecture. Okay. Okay. You don't need to stand all in the front. Maybe you can just stand up. And I have my 360 photo, okay? And you can circle around. Okay? Okay? But maybe some of you are that are too far, maybe come a little bit closer. Okay, maybe right here. Circle around me. Okay. And enjoy the moment before final. Okay, maybe come closer, closer. Stand up and come closer. Nggak apa-apa. Tutupin pakai hoodie biar nggak kelihatan. Yeah, please come closer. Come closer here. Come here. Come here. Come closer. Maybe fill in this row. Maybe some here. Yeah, come closer. Come closer. Yeah, come closer. Come closer. Yeah, come closer. Yeah. And look at the camera. Okay, look at the camera. Okay. Okay. One, two, three. Okay, let me check first. Let me check. Let me check. Oh, some students not looking at the camera. Let me try one more time. One more time. Look at the camera. Camera. I think I think the one there is blocked by someone. Maybe you can go here. And yeah, you also yeah yeah yeah. Also maybe here because yeah here. Yeah, go here. Okay. Oh, one more. Look at the camera. Look at the camera. And one, two. Okay, let me check. Okay. I think you move so a little bit blur. One more. Okay, see the camera. Okay, one, two, three, and smile. Okay. Okay, I think it's better. Okay. And now your quiz, your quiz. Okay, can you help me? Can you separate the local student and the so it will be question and answer. Okay, this is Taiwanese student and this is the international student. Can you come make one of local student come? Oh, this you. You're right. Yeah. Yeah. You check the name. You check the name. Eh, no. Michelle. Uh, not Michelle. Another Michelle. Kimberly. Uh, Julio. Can you check the name and then Dani. DIY. Brian. Cafe. 16, 2, 16. Okay. What's that 31? 36? What's 36? 32. 27, who's 27? 25. Oh, it's not coming. Right? Thank you. No, not coming. Number 9. 35. 35. Number 7. 29. I think Tony. Tony. Doron. 46. Who's 46? No, 46. 20. 34. Who's 34? Oh, William. Tom. Number 2. Number 2. 43.